Thank you for being with us today. My name is Christine Dallinger, and I welcome you to today's NEWBITS webinar entitled Developing Innovative Business Models for ITS Applications by Using a Value Network Approach. Today's webinar is in fact the third in a series of 4 webinars that will be delivered by experts from the ITS project NEWBITS. These webinars have been organized with the aim to share unique insights from a novel collaborative approach to design new business models for ITS. And let me just start with a brief technical announcement for today. So if you have questions, you're invited to write them in the chat box. We will collect and address them after the presentation. And of course, you're also invited to send us further questions that may arise later via email or leave your email address in the chat box. The recordings of this webinar will also be made available on the NEWBITS project website. Now, this webinar gives you a comprehensive insight into the tailor-made value network approach, which has been evolved within NEWBITS. This value network approach aims at supporting the development of innovative business models for ITS services in Europe and combines 3 methods. First of all, gathering stakeholders and motivating them to cooperate. Second, identifying where value lies within a business network and how it's delivered throughout the network, and crafting value propositions and business models. So in the first 2 parts of the webinar, you will get to know the NEWBITS project and find out how to use a value network-based approach to craft new business models for ITS services. While in the last part, you will understand the importance of the dynamics of intangible value flows between stakeholders. This webinar will be delivered by experts from Otelio and the Autonomous University in Barcelona. It's an honor to introduce today's speakers to you. This is first Viara Bojkova. She holds a master's degree in economics and philosophy from London School of Economics and is currently working as a senior economist at Otelio. She has provided advice to the public authorities in the UK and Europe. And since 2015, she's been contributing to various Horizon 2020 projects, among which there are SIPTEC, NEWBITS, and Noasis. And second, we have Miguel Angel Piera here today. He holds a master's degree in control engineering from the University of Manchester and a PhD in computer science from the Autonomous University of Barcelona. And at present, he's a professor at UAB, has coordinated and participated in various EU projects, and is also founder of the ITS spin-off company S-Logic, where he contributes to innovation processes of new services and products. And with no further ado, let me hand over to our first speaker, to Viara.
Thanks, Christine. So I'll start my presentation with sharing a few facts about our project NEWBITS. And NEWBITS means New Business Models for Intelligent Transport Systems. The project has been supported by the European Commission through the Horizon 2020 program in Europe. It began in October 2016 and is expected to finish in March 2019, as it is coordinated by a technology company, Ortelio, based in the United Kingdom. And the whole consortium includes 9 partners from 6 EU member states. These are Atos, based in Spain, University Autonomous of Barcelona in Spain, TTS Italia, Isinova based in Italy, Intel based in Greece, CDEV based in the Netherlands, Steinbeis Europe based in Germany, and Coventry University Enterprises. The key aim of our project is to understand the conditions that affect the intelligent transport systems innovation deployment by using an improved value network-based framework. And this framework first minimizes the failures which are inherent to the ITS and CITS innovation diffusion process. Second, involves the current existing business models. And 3, identifies the effective incentives to accelerate ITS and CITS deployment. The overall NEWBITS approach aims to set up a systemic way of establishing ITS networks and shape their business models. The methodology is evidence-based, and the evidence was derived from 4 case studies. I will briefly explain each of the case studies. Case study 1 is about the university carpooling service in Spain. It is a good example of the observing collaborative consumption in our sharing economies nowadays. The service is based on a developed ITS platform that matches users to vehicles in order to reduce unnecessary trips. Case study 2 is about urban traffic. It is an example of the developments of the Internet of Things and Smart Cities CITS platform to monitor drivers' behavior and also forecast which is an example of how smart data analytics and real-time information can improve the logistic chain. And our last case study 4 is about the railway maintenance solutions in the United Kingdom, which represents the use of big data analytics and visualization service in infrastructure assets to avoid unplanned repairs. In order to understand in any deployment of the ITS innovation, where we have an involvement of many stakeholders, we established 3 methodological stages. In stage 1, we defined the relevant case studies, and I already explained the 4 case studies of NEWBITS project. In stage 2, we applied key concepts that can be extrapolated to the ITS domain. In the NEWBITS project, our main concept is the business ecosystem. And in stage 3, we formalized the model by developing a 5-step tailor-made value network analysis. What are these 5 steps? In the value network analysis, the main term that is applied is the value flow. And the value flow outlines the output of one stakeholder as an input to another. In a way, the flow represents the delivery of value from one stakeholder to another. For this purpose, we developed these 5 steps in order to be able to identify all the value flows between the stakeholders in our networks. In step 1, first we identified the network. In step 2, we identified the stakeholders or the actors of the networks. For this purpose, we ran qualitative stakeholder analysis. In step 3 and 4, we ran a quantitative analysis, which was based on a survey with the stakeholders and then a direct interaction with the stakeholders through ideation workshops. Based on all this gathered information from the 4 steps, finally in step 5, we designed the business model vision and the governance of the network, which was all again with the contribution of the stakeholders. The value network analysis, which we applied in the NEWBITS project, was simultaneously applied in all 4 case studies of the project in 4 different EU member states. Here in this presentation, I will give you an example just with case study 1, so that everyone understands what are the practical steps. Case study 1 is the Value Point Mobility in Barcelona, which is an intercity carpooling platform. It offers an intelligent carpooling service for daily mobility to the campuses of the university. The university is one of the largest public universities in Spain, and it has large campuses outside Barcelona. For this purpose, it offers to the members of the university community this service that can, and they can access numerous car sharing options. The size of the network is relatively large. It consists of 10 stakeholders. The direct value flows or the interactions between the stakeholders, which we identified, are more than 100. The indirect value loops, which we identified are more than 1,000 in this network. And this is the value loops represents the value chain, which includes 2 or 3, even more stakeholders. What we did with the stakeholders, we categorized them in 3 different groups. The central stakeholder, which is the stakeholder with the largest proportion of interaction in each of the network, and in this case is the Autonomous University of Barcelona, which originated the network as a knowledge hub initially, and then it evolved into a distinct network. The second group is the primary stakeholders, and in this group we have Logic, which is the ITS provider, 3 research units of the university, the frontier cities, which is the funding body, members of community, which represents the end users of the service, and these are predominantly students, and also some academic and non-academic staff, and Websales, which is the social media marketing company, which engages very much with the end users. And the final third group are the secondary stakeholders, which do not have a direct interaction in the network, but the government and the educators. In this case, the government provides the regulatory and the legal framework, and the educators provide the skillful workforce. In step 2, we identified the stakeholders. We ran a qualitative stakeholder analysis in order to gather information from the stakeholders to understand how each of them contributes to and derives value from the network. To see clearly the interactions among stakeholders and whether they were satisfied with the inputs received from other stakeholders, we followed a template that concisely specified their role, objectives, needs, inputs and outputs, costs and revenues. In general, when we speak about stakeholders, we take into consideration only those who first have a direct or indirect involvement in the core activity, second receive direct or indirect benefits from the core activity, and third possess a significant legitimate interest in this core activity. For instance, the regulators are such stakeholder. In our network analysis, each stakeholder is treated as a node with links to the rest of the network. And in step 3, you can see these links between all the stakeholders. This is a value flow map, which is colorful, and it represents all the value flows among all the stakeholders. For instance, they represent different types of value flows, and that's why they are painted in different colors. The blue value flows are the monetary value flows. The red ones are the knowledge and informative content value flows, and the greenish links relate to the policy engagement, policy collaboration, policy direction. In this network, there is a concentration of activity around the University Autonomous of Barcelona and their research units. There are 2 circles, important circles. One of them is the exchange of interoperable new standards and a transfer of technology, which begins from Logic and goes to the UAB Smart Cities Core, one of the research units of the university. And the other one is from Websales, which is again an exchange of data, which is collected, detected in the campuses. Then this data is statistically analyzed, structured, and it is utilized by UAB Logger and UAB Smart Cities Core. Also, part of this data goes to frontier cities. So this network of case study 1 heavily depends on the exchange of data, technology, and knowledge. In the final 2 steps, we ran quantitative analysis and design finally the business model visions. The quantitative analysis, the idea of the quantitative analysis was to give us some understanding of some quantification of the value created within this network. It was based on a surveys run in December 2017. Then from the results, we calculated the value flow scores, which were validated by the stakeholders directly through the ideation workshops. At the third level, we had joint group discussions with the involvement of some external experts that did also ranking to the value flows of the network independently from the stakeholders. And then we calculated the value loops and ranked also the stakeholders' major interactions. Based on all these quantitative measures, which gave us an understanding of really of the quantity of the value that the network creates, we made conclusions for each of our case studies and made recommendations, particularly for the central stakeholder, in what are the situations or the parts of the network where the value creation process can be improved. Based on all the conclusions from all our 4 case studies, there are 2 major outcomes. And the first is that each network should provide innovative products and services based on ITS applications such as platforms for commercial use, but also for educational and public use. And the second outcome is that in order to improve the political support for the ITS markets in Europe, each network needs to produce the necessary informative scientific content supplied to the national governments or regional or local governmental departments with the intention of improving the communication with policy makers. Thank you very much for your attention, and I will pass the floor to the next speaker, Michael.
Okay, I hope you can see the presentation in the screen. To support the results of the quantitative analysis of the value network that we perform in the different case studies, mainly in case study 1, we realized in NEWBITS about the importance to get a deep understanding of the dynamics of the relationships between a stakeholder. I mean, the evolution of the interdependencies to enhance them with true cooperative mechanisms. There are several open questions that can affect drastically the behavior of the members, and in consequence can be the source of innovation failures, creating more barriers than enablers. There are some open questions, such as, for example, do I adapt the competence of my company, or is better look for a partnership with the right competencies? The answer to this question will affect future competitors. Also, aspects such as, for example, the profile of a new member in the ecosystem. Both aversion to the innovation risk or excessive enthusiasm in the innovation could be a barrier or an enabler for the business ecosystem dynamics. Questions about how to organize the flow of know-how among partners. By sharing know-how, synergy can arise. However, also sharing know-how can lead to a weakness for one of the partners, creating a new competitor in the future. Other aspects that also influence the dynamic of the relationships between the ecosystem memberships is the question about the cost of the final product or service in the innovation with respect to the utility, the usability, and the likability aspects. Each one of them has an impact. Looking for a new partnership or extending the competence will impact on the time to market. Cultural barriers among stakeholders, trust, and acceptability are some key questions that should be properly analyzed as intangible flows between ecosystem members. See, in NEWBITS, we have been trying to understand all these dynamics from a socio-technical point of view, instead of just social network. In a social network, when creating a network of stakeholders, the initial objective is mainly related to risk and supporting cost. But in a socio-technical approach of a business ecosystem, we realize the importance of these intangible flows that somehow has also some dynamics. Consider, for example, trust. Trust among the stakeholders cannot be represented, neither observed. So in a socio-technical approach, we have, from one side, the innovation aspects to be implemented by adapting market technology to provide a new service, or also we should consider all the human aspects that affects the business ecosystem. That's why in physical networks, main problems can be described from an engineering point of view, where the interface is very well known. That's why we use arrows. However, when we talk about the social aspects, such as, for example, trust, positive experience between stakeholders, which are critical to overcome barriers and enhance enables, there is no easy understanding of the interface and the interdependencies between them. That's why in NEWBITS, we consider as a complex systems and we use beams to represent these interdependencies. Furthermore, these interdependencies, the intangible flows, cannot be measured, neither observed or controlled. And in the physical now, we can observe and control the evolution of the adaptation of the technologies. So in NEWBITS, and in particular in the ITS area, Intelligent Transport System sector, in order to reduce the time to market and increase the acceptability of the innovation by engaging early adapters, we consider the business ecosystem as a complex adaptive system in which both dynamics should be considered at the same level. How the integration and the technical problems can be solved, and also how the dynamic between the stakeholders are providing the right atmosphere to succeed and reach the market through an adaptive cooperative behavioral mechanism. So we can see by this approach that we can face multiple loops and multiple feedbacks between stakeholders and components. It's very easy to understand the interdependency between the technicians of the different companies with respect to the designers. And also, this network of communication between technicians and designers will affect the commercialization and also the industrialization. So all these aspects should be considered in an ecosystem, together which are the main inhibitory interdependencies, usually early beginning in an ecosystem. IPR used to be one of the main blockages, which are the preferential reactions, and also to consider that the business ecosystem, despite the stakeholders maybe are the same as the initial constitution of the ecosystem, the dynamics change. And that means that the role of each one of these members can change, and we should adapt the network, the socio-technical network, to the new dynamics. To better understand the business ecosystem as a whole, an analysis of its structure is required, considering the integration of the physical network with the social network. Some aspects to be considered are, do we have the right amount of stakeholder? How members' competencies could complement in a cooperative framework? How value could be created by putting together their assets and skills? These are key questions that affect drastically the social dynamics, while the robustness of the technical part is more related to the risk sharing in the integration and the development of the adaptation of the technology, and also the competitive time to market to reach the product or the service at the right time. So in NEWBITS, we have been trying to formalize these hidden dynamics, which can determine the future of the business ecosystem. We have been using agent technology to formalize these dynamics in order to describe both how tangible and intangible values affects a particular stakeholder, which are the positive or negative externalities that affect this stakeholder, and how the status of the other agents affects its own decision. So we try to understand the business ecosystem as a set of interdependencies between the different stakeholders, each one described by a fixed amount of attributes: financial risk, trust, economical benefits expected by the stakeholder, engagement of the stakeholder, and technological risk assumed by the stakeholder. So understanding all these interdependencies will allow us to design new mitigation mechanisms to drive the business ecosystem to a successful result. Some key characteristics that in NEWBITS we realize it and we formalize it in case study 1 are engagement. It represents the importance of the stakeholder in the ecosystem, and it's measured by the amount of stakeholders in which it can influence. Trust. Sharing organization know-how is an important enabler for the ecosystem as a whole, but it can weaken the role of the stakeholder in the ecosystem if its competences can be absorbed by other stakeholders. And finally, technological risk. Despite some technologies has been tested and validated, its integration in an intelligent transport system development have inherent risk. This attribute consider only the technological risk of the stakeholder to fit the ecosystem expectation. In the particular case of BowPoint, case study 1, we focus mainly on UAV mobility. We collected the data and we observed that the occupancy of more cars, of the cars arriving to the university, used to be 1.2 people per car, which is difficult to understand if we consider that nowadays most universities increased the fees rates. At the same time, we have seen that the main aspect conditioning the car is the solo driver behavior, which is travel time, flexibility, and autonomy. And the prototype developed in this ITS case study was an app that just adapted the present well-accepted technology. We adapted a router to obtain which is the best pathway to collect people from Barcelona area to reach the university. So grouped potential users by sharing the cost of the ride. And also we monitored the traceability of the mobiles of the students just to be sure that they are using a carpool service. As a result, we implemented this socio-technical model to understand why some loops and the value of some loops and its evolution. For example, in this picture, we can see that early beginning, it was tried to manage the use of this app only by UAV management and UAV logistic unit, because somehow one of the awards by using this app was the facility to obtain a parking area, which is a scarce resource in the university. And UAV unit tried to obtain the best routing policy to make easy to collect students from town to the university. However, later on, we realized the benefits and the values by introducing the members of the community, because in this case, we could understand the affinity. Which are the main objectives to avoid the solo driver behavior? Which are the benefits and the awards that end users and passengers could expect from a service like about a point. And in this case, we realize the importance of a new stakeholder that provide data analytics to monitor which are the feedback from the members of the community that will affect the new design of the tool in order to obtain a success and a good acceptability of the tool. So, as conclusions, we have seen that business ecosystems provide a framework for a better understanding of the changing conditions and dynamics that affect or influence ITS innovation. New KPIs should be designed to fit reactive network-oriented value creation propositions that improve the collaborative decision-making process across the various stakeholders in order to minimize the failures which are inherent to the ITS innovation diffusion. For more information, you can download the Libro 4.1 and 4.3, in which case study 1 is described, and also the importance of the agent technology to represent these intangible flows. I thank you very much for your time and attention, and I give the floor to Christine.
Yes, thank you very much, Miguel. Before we close, I would like to take the opportunity to draw your attention to 2 additional NEWBITS webinars that you can also access for free via newbitsproject.eu. The first one, entitled Unveiling the Potential of ITS Applications and Services in Europe. This one actually presents results from a conjoint analysis, a statistical marketing research technique, discussing which elements of an ITS service are key for a potential user, and in addition, providing market insights that we gain through an investigation of selected ITS markets in Europe. And the second one on communities of interest for the advancement of new collaborative business models for CITS products and services. This one shows the benefit of communities of interests and exchanging accumulation of different stakeholders which share common goals, interests, and environments, and it will show how these communities can create momentum to drive the development of new business models. And further, in this webinar, you will see the functionalities and tools of the new online ITS collaboration tool, the NEWBITS network platform. And on the last slide, if you want to stay in touch with us, you can access further reports of NEWBITS on the webpage, sign up for our newsletter, follow us on LinkedIn or Twitter. But most importantly, you can join the NEWBITS network platform, which is a newly launched online collaboration tool for ITS services, which you can access via newbits.eu. And basically, all interested parties from the field of intelligent transport systems can register here to exchange knowledge and to independently post events, products, services, cooperation and financing opportunities online. And the aim is to accelerate the market launch of new products and solutions in the area of ITS by bringing together relevant players. So go and visit and feel free to register on the NEWBITS network platform. And again, thank you very, very much for joining us today. Goodbye.